let's begin from the little agenda. The first topic will be how to have a free transactions on Scale, and the second topic would be about decentralized storage. Okay, let's go from the first topic. And really, to start with, I would like to ask you, raise your hands, who will be coding? Who will be coding to understand? 1, 2, 3. Oh, no, you just give it. Okay, okay. 1, 2, 3. Yeah? 3. Ah, okay, you're writing. Like, okay, I have like the version for notebook and pen. Okay, so 2 people will be working with me, and other will be like staring on this. Okay, so the topic number 1. It's about free transactions on Scale. You think, how could you do the free transactions, and why do we need in real life the free transaction? Of course, everyone wants to have a free transaction, but in a real world, there are some cases that these free transactions are really needed. The first one is for dApp, but why? Why? What is the first step for dApp? What do you think? I think that the first step for dApp, after you deployed it to the network, to the mainnet, or where you Rinky Biron, Robson, or other stuff, is to have customers and to onboard them to your dApp. But how could you do this if they have no money? For example, you wanted to create your big social network on a blockchain. Then each of the users should have an account that have some money on this account to make some interaction, to for just registering. Yeah. And how can you do this if you have no money? You cannot even register in this social network. So someone should maybe send you some money, or someone should just give you permission for this network, for this social network. But we found a solution. A solution is pretty easy and pretty elegant. It calls proof of work, but this is not a common proof of work. It's not a common proof of work. It's a proof of work for client side that will work with our S-chains, with our blockchain that is on our SKALE network. Okay, so how could you do this? How can you get this money? You cannot get it just from the air. So you need to do some work to get some free gas for transactions. When I mean the free transaction, I mean the free gas transactions, not a free money. You cannot just mine 1,000 Ethereum like this. It would be нечестно, like untrust. So in this case, the main solution, the main problem is to get this free gas for transaction. If we can get the free gas for transaction, then our client could use this feature and send the transaction to our network, for example, for registering for our big social network. And other stuff is for example, some functionality needs to be realized, implemented like transactions. So you cannot make a call and just get some stuff, some result without any transaction. So in this case is very easy to understand on the example of the browsers and smartphones. For example, the advertisements, for example, the application that give you some money on your account when you click on the advertisement and go to this site. So you need to verify that it's you. So you need to send a transaction that is signed by you, by your private key, and then blockchain understands that it's you and you need some money. So in this case, this feature is used too. So, and the main question, how it works. I wanted to ask you one thing. How many of you are working with Solidity? 1, 2, 3, 4, 5. 5. And I think the most of us is acquainted with Web3, Web3.js. I hope yes? Yeah. Raise your hands. Okay, raise your hands who acquainted. Okay, because the other stuff that we will do for the workshop will be related to the Web3, Web3.js, and Solidity. So, okay. Let's go forward. So, what work should you do to get this free gas? For getting free gas, you should find such a 256-bit hash, and you will get and send it to our S-chain, to our blockchain. In this case, you will get the specific number of gas for this hash, and the amount of gas that you will get for this hash is counted for by this simple, maybe not so simple formula. It is the XOR sum between encoded address, encoded nonce, and encoded gas price, and then this new hash is like is used for counting the free gas in the meaning when you will receive in this free gas. So for just these two lines, just these two formulas are getting into the EVM, into our EVM, and allows us to calculate the amount of the free gas that each of the user could get from this hash. So, okay, let's go forward. And so, how could you send this? The first question: how could you send this hash to the S-chain, to our blockchain? The reason is the SKALE and S-chain is not even used the gas price, so we do not even look at it, because we have other algorithm to work with transactions and work with the transaction queue. It calls consensus, and on our other panel, our CTO Stan Klatko is talking about this. So, and then this option, this field in the transaction, that gas price, is empty and could be filled like whenever you want, whenever hash you want. And we are looking at this specific place to understand what is the hash that you have sent it, and to calculate your free gas after this. Okay, so it's a little bit theory, a little bit introduction, and then I propose to do some workshop, and let's get some money, some free money from our S-chain. So could you raise your hands once again who is gonna to work with me? Okay, one. No, you will work with me. Okay, so then I can help you in other will be like understand what is happening. So I will be working on my laptop and help you how to do this. So the first thing is I have prepared some template for client-side POW, for the client-side miner that you can use. So just clone this repo on your laptop. I already huh? Okay. Oh yeah, you're so quick. Okay, so the next thing is what to do is to have you. I remember. I forgot. Have you have a background in Web3.js? Oh, great. So then what you should do? You should firstly connect to our chain. Maybe you have MetaMask on your laptop. I think yeah. So you can connect to our chain endpoint that I have created for just for this workshop. You can link to it. You see. Yeah, yeah. MetaMask, the chain ID. I can send you a chain ID. Okay, yeah. Okay, okay. Maybe. Oh, yeah. It will be better if you send me it in. I will send you it in Telegram. Okay. Yeah. Hmm? Yeah, I mean the chain ID for MetaMask. Yeah. No, you can 4109 E3OF 3A 101. Just type in your MetaMask. Okay. Let me. It will be better, I think. Okay. So have you connected to S-Chain? Okay, okay. Yeah, so, and now you have an account that is like have 0 Ethereum. And I will do the same from my side. So now I have connected to the workshop, okay, to the workshop S-Chain and have 0 Ethereum on my balance. So what I can do next? Then you can use our template for especially the module POW or scale miner.js to use it as the client lib for the POW, for the forwarded POW client that you will write today for getting in your free tokens. Okay, so what we will do, we will open this scale miner.js from the POW demo. Yeah, and here is two functions that I already created. This is like a template that you will be like playing around. So in this module, let's open it and write the new function for sending to sending some transaction on our chain. The chain endpoint, you have your chain endpoint, you have your private key from the MetaMask. I don't ask your private key. So let's see. Oh, it's pretty easy for me because I already have it in my template, but you also can do the same stuff. Firstly, you should write your for a function on the Web3 just for sending transaction. Yeah, let's. Hmm? Yeah. You can do this in Scale Miner. Yeah. I already write it. So. Hmm? No. Use it in Scale Miner.js. Too simple. Yeah. It's in a poll test.js, the template for this. You can copy, but yeah, so okay, let me help you. Okay, receive funds. Yeah, but you need not receive funds. You need the test receive. Yeah, test receive is for no. It's you can just copy or can use it like in this module. All right. Yeah, and then you can call this. You can, for example, create .env file to send all your credentials for this test, and then just call all this stuff from this function. Yeah, so you need a Web3, you need a test key, you need a contract address, and you need a receiver address. A contract address I have already posted into the slide, so you can check it, and or maybe I can send it to you. Okay. Yeah. Let me check the Telegram. Could you send me your nickname?
My Telegram?
Yeah.
Okay.
Okay. So let's connect and pass these arguments to this function and trying to run all this stuff. In receiver address, you should pass your address that you have passed in MetaMask. Yeah, and as process and private key, you can just pass your private key from the same MetaMask. Okay, so if you do each step, then you can run the script and then check in your MetaMask balance. Yeah, just make a node, like, node poll test, that's it. Have you installed NPM packages already? Oh, great. What? Yeah, yeah, yeah. Not receive funds, not receive funds, but here I said the test receive.
Oh, okay.
Yeah. So test receive, like receive funds is used for HTML, for Web3 from that is getting from the MetaMask, and the second function is used for Node.js. Okay, tell me when you. Oh, okay. Mm,
Right, there's no Web3. Maybe we can just go like.
no. I mean, you should write the function that calls test receive and that initialize Web3.
Oh, okay.
Yeah, so yeah, and do the stuff in this function, I think. Oh, okay. You can do this like that. Yeah.
Okay. Oh, by the way, this is an ephemeral key that I'm gonna throw away, so I don't really
Mm?
care. This is a key I'm throwing away, so I don't really.
Mm-hmm. Okay. It's better to create the new function right in this module, and in this function, for example, call it run or start, and in this function call the test receive procedure, and also initialize Web3, initialize all your credentials, and just pass it to this function. Yeah, and that's it. Yeah. So you can run.
Like I can run it, but nothing's gonna happen, right? Because I'm not actually calling it.
You should call it.
Is it like with a default provider or something?
Look. It's better to create a new function and initialize your Web3 in this function, and then like run. Just call the run this function.
I usually use ethers, so I'm not too familiar with
Hmm?
Web3. I usually use ethers.
No. Okay.
I'm just asking, what's the Web3 thing for default?
Web3 default. No. Oh, hi. You should.
Provider, I can't run this.
You shouldn't run it in browser. You should run it like from your laptop, from the Node.js. Just pass the scale endpoint that I have passed to you into the Web3. Hmm? Okay, yeah. But you already connected it through MetaMask. Okay. Okay, so you can do as I do. No, it's like I do it like in a 5 minutes before presentation. The example of this run function. So you can do it by yourself, or you can do as I do. Just initialize Web3, then just pass your URL that I have sent it to you to the Web3, and then call the test receive, and that's it. Yeah. Let me check.
Oh no, I just have to.
Okay.
Free guess.
But it takes some time to mine in free gas. Why? So, oh no, don't worry. So, uh, as I said, when you're sending you're sending to the scale just one hash, and SKALE just checks whether the resulted free gas is more than, for example, for this transaction is needed. And what on the client side is doing. So in the loop, we are trying to find such hash that is allowed us to have the free gas value more than the estimated gas for this transaction. So, okay. So tell me when you will finish. Okay. And now check your account in MetaMask. Oh yeah, one is. So you can get one is. Why? Where is this one is from? It is from just a simple contract that is sending you one is when you are sending a transaction. You are just sending a transaction to this simple contract, and the contract is like sending you this one is. So let me show you. Yeah, it's pretty easy to. It's pretty simple contract that has two functions: that get balance and pay. I don't. Oh, if you cannot see, I can zoom in. Make a zoom in. Okay. Zoom in PyCharm is not so easy to find. So if you are done with this, we can go to the next part. The next part of the workshop is about deploying contracts and how we protected our S-chain from the unreliable smart contracts. You know, not some customers, some S-chain owners don't want to have some vulnerabilities, some vulnerable smart contracts that are like, for example, stealing money or sending some scam to the different accounts. And in this case, we created our new protection system for the deploying smart contracts. So how it is done in Ethereum? In Ethereum, there is no protection at all. You can deploy everything you want, just paying some gas, and here you are. Here is the smart contract on the blockchain, on the network. But in this case, as I said, there could be some malicious contract, some fake tokens, and other stuff. And so what we are doing, we are inside our EVM, we are fully based on Ethereum, and our machine is fully compatible with the EVM from Ethereum, from Alice. Yeah, and what we are doing, our chain has inside it one more pre-deployed smart contract. This smart contract is just working as other smart contracts, but what is he doing? The first difference from others contracts that it's pre-deployed. So it is works from the start of the chain, and who knows about pre-deployed contracts? Raise your hands. Oh, pre-deployed contracts. Okay. A little. Pre-deployed contracts, there are several types of smart contracts. The regular smart contract is the one that you deployed through the Remix or some other stuff, or from Truffle. But there could be some contracts that already has its own addresses from the start of the blockchain, and these contracts called pre-deployed. It is done in Ethereum. There are some pre-deployed already, even in EVM, and we just expose the number of these pre-deployed contracts with one more. And this new has its own functionality to just checking, to just validating the one who is sending the transaction with the like contract deployment transaction, and checks whether it's valid or not. And after this, it decides, could we create a new contract or not? So that's it, and you can now check. You can now check the this mechanism if you are using Remix, for example. Or yeah, I recommend to use Remix. Write simple contract and trying to deploy on the same endpoint that I have sent to you. Maybe someone also want to deploy it. Okay, if you wanted to, just raise your hand and I will come to you and show you how to deploy the contracts on the S-chain through the Remix. Okay. No one. No. Okay, but I got this. Okay. So let's open the Remix, just connecting to our S-chain, and after this, trying to deploy something. Yeah, no. Okay, you already connected from through MetaMask, yeah? Yeah, so you can take the contract that I already put in this template in the POW, and for example insert it into the Remix and try to deploy it.
How do I connect? I haven't used Remix in some time. How do I connect?
Not JavaScript VM. Okay. Let me show you. Okay. Yeah. And have you connected to the MetaMask? Okay. So now try to deploy, and you will find that you cannot deploy it on our chain because your address is not. No. Not like this. So you need to compile it first and then deploy. Open. No, not here. Yeah, compile. Yeah. And deploy. Yeah, try to deploy it. No. So you can adjust your gas limit, but it doesn't help because your address is not whitelisted. So you can send me your address and I will whitelist you. In other cases, so the process, the pipeline of the deployment contracts is that the S-chain owner will validate will whitelist the address by itself. So we have all tools. We give all tools to the S-chain owner to decide whether this contract can be deployed from this address or not. By default, only S-chain owner could deploy contracts on this on blockchain. And other contracts also can deploy another contract. So if there is a contract on the S-chain, then it was deployed from whether either whitelisted address or S-chain owner address. So in this case, it could deploy. Yeah. Okay. So I have some time to show this the next presentation. I will whitelist your address and after this presentation, and we will deploy the rest of the contracts. Okay, so the second part is about a decentralized storage. So as we creating the layer 2 solution, the multi-chains that are fully compatible with Ethereum. But one more stuff we have in our S-chains. It's fully implemented and fully integrated storage for storing your data right on the blockchain. So it is fully on our network, fully on our S-chains, and all the data that are coming to this blockchain are gonna from the transactions. And from the transactions, they form the new files. They also, because of this, we have the fast and easy access to all these files. So you are deploying, or you are uploading them into the file storage. You are deploying them on in the blockchain, and they are storing. They are storing there, and for example, someone wanted to get access. How he can get this access? Pretty simple. Just from the URL. He types the URL in his Chrome browser or Opera browser, and then just download this file. Yeah, for example, this is the example of such URL. So it's pretty easy to understand the IP. So there is, as host, we have the host name of our machine, of our node, that is one of S-chain node that is working for our S-chain, that is having the file storage in it included. Then we have the S-chain name, and after this we have these strange symbols. What is them? This is the owner of the file. So the owner, the file for a file, there could be only one owner. So in the file storage in one S-chain, there is only one such string and couldn't be another one. So this address that is on the slide, it couldn't create the new file with the same name. And for example, and this file GPG could be created by other account, but you can get access to those files by other URL. Just change your address, and how much will be costed for you? It will cost you only 0.00001 Ethereum per 1 megabyte for our chain. It's to be truthful, it's Ethereum that is on our machine. It's SKALE Ethereum that is like the currency inside our chain. So you can get, for example, you wanted to create some file, to upload some files into the file storage, and you haven't got any money on your account, but you wanted to do this. Then in this case you can use our part 1 solution, our POW solution, to send this transaction with POW, and this transaction will be on S-chains. So not only these files, but not only this transaction, but the files also. And it will be cost you much less than Ethereum. For example, in Ethereum, what is the block limit for data block limit? It's I have looked it yesterday, and it was 20-30 kilobytes. So this transaction could even be on Ethereum. But on our chains, we could send this such a big transaction for 1 megabyte, and our chains are simply working with them. Yeah, and so these three steps, these three features, allows us to build a powerful and working file storage that will store the file on the blockchain for the Web3. And you can, what is the purposes of this? What it can be used for? For example, you creating your Web3 site, and you are writing your logic, your functionality as smart contract and deploy it to the S-chain. But what if you wanna? But what if the servers that are hosting your front end goes down? Then you will not have an even UI to interact with your application, with your site. And in this case, we propose our file storage that will be hosted the sites on the blockchain, and like the smart contracts will be working with the websites. So if one of the nodes will be falling down, then others will be still working, and this site will be like working for you, for user. Yeah, so how it works? The principle is several layers. The first layer, the highest layer, is not even file storage contract. It's the API for this file storage contract that we already have. You can check it out on our GitHub pages, on our GitHub repo. It is called file storage.js. It is nice library to interact with all the features, all the stuff in the file storage. The next layer is file storage contract itself on our chain. So it is a smart contract that manages all stuff related to files, creating them, deleting them, uploading the new chunks, downloading the old chunks, and other stuff. Yeah, and how he creates the files, because the regular Solidity couldn't do this. Then our EVM is, as I said, fully compatible, but we have done some upgrades to this EVM, and we have included some new precompiled contracts that are allowed to interact with files and to allow the uploading, downloading, and other stuff. Also, as I said previously, we are if you will be hosting the website on our chain, then it's not only for files, then it's also for directories. So you can create your own tree, like file tree system inside this file storage, inside the blockchain storage, to easy to interact. And then in this case, this URL will be counted as the same in the same way. So the address slash the folder directory A slash directory B slash your file. Yeah. Okay. So EVM is creating and interacting with file system of each of the node in the S-chain, and creating and deleting other directories, files, and other stuff. Yeah. So this allows us to easy interact and create and download file. So for downloading file, we can download it chunk by chunk, but we created the new solution. And this solution is, we have the separate Nginx server that is serves all this file inside file storage for downloading them. So you can just ask the node for this specific file, and then this node will be give you. And you can download it right in your browser. So that's it for me. If you have some questions, you can ask them right now. Yeah. Okay. So clear for you, even without questions. Okay. Yeah, yeah. Hmm? Yeah, S-Chain is a layer 2 solution. It is multi-chain that is fully compatible with Ethereum. That is like working. This EVM is the updated Ethereum virtual machine that we have updated with a little bit for our new features, for example, for this file storage. But in totally, we are not only compatible, we are working in Ethereum because our contracts are on Ethereum, our virtual machine is based on Ethereum virtual machine, and so on and so on. So all your contracts, all your transactions that are working in Ethereum will be working in our chain. So that's it. Yeah. Okay. So do you have any questions? Okay. Then nice to meet you. Nice to present our new features for you, and special thank you for this guy who was working with me all this time. Thank you. Okay, so nice to meet you.